Hey everyone, Dr. Tom McNamara back here again for our course in trigonometry. In this video I wanted to discuss something called the law of sines. Now here I've got a triangle. Notice it's not a right triangle. And I'm following our labeling convention. The angles are indicated with capital letters. And the side opposite that angle is labeled with the corresponding lowercase letters. So capital A represents an angle here at the corner. It opens up on the side A. Angle C opens up on the side C. Angle B opens up on the side B. Then this is what the law of sines tells us. The law of sines tells us that these ratios are always equal. So if I take sine A over side A, that should be equal to sine B over side B. If I take sine B over side B, that should be equal to sine of angle C over the length of side C. And of course I could eliminate the middle too. Sine A over A should be equal to sine C over C. And this is actually a really helpful thing for doing some indirect measurement and solving triangles. We'll look at a few examples in a sec, but I just want to get a feel for why it's true. And as I mentioned, this is not a right triangle, so the material that we talk about with right triangle trig doesn't directly apply. So what we're going to do to understand why this is true is we're going to drop in a little perpendicular. We're going to go from the peak of the triangle and drop down to the base, side AB, okay, or side C. Okay, now, if I were to look at, let's say, sine of angle A, well, it would be opposite over hypotenuse. Okay, so here I'm focusing on this right triangle. If I'm talking about this angle, here's the opposite side, H. Okay, so sine A is equal to H over B. And let's look at from this perspective. Sine B. Well, if I'm looking at this angle, there's my opposite, and my hypotenuse is side A. Opposite over hypotenuse. Okay, so both of these equations are true. We can solve it for H. Okay, this first equation says H equals B times sine A. And this second equation says H equals A times sine B. So this expression is equal to H, and so is this expression. So those expressions must be equal to each other. B times sine A would have to equal A times sine B. And of course, that equation is equivalent to this one right here. Okay, I would divide both sides of this by AB. That way the B's would cancel here and the A's would cancel here, and I would be left with this, which is the first part of the law of sines. Okay, you can get the other part by drawing a different altitude and bringing in angle C into the mix with some right triangle trig. Okay, so this is the idea of why the law of sines is true. So let's look at an example or two where we use the law of sines. Okay, let me pull one out of our textbook here for us to work on. Okay, so triangle ABC, where was I? Angle A equals 40 degrees. Angle C has a measure of 60 degrees. And A equals 7 inches. Find the length of side B. Okay, so I'll get myself a little picture. Okay, following the labeling conventions that we've been using the whole course, right? Angle A opens up on the side A. Let me write down the information that they've given us. They tell me that side A, which is over here, is 7 inches. They tell me that angle A measures 40 degrees, and they tell me that angle C measures 60 degrees. All right, now, using the law of sines, I know that sine A over A equals sine B over B. All right, so I want to use this because I know side A, I want side B. So I want to have the version of the law of sines with A's and B's in it. Now the thing missing is angle B. They haven't told me that, but in a way they did. They told me the angle indirectly. Of course, we know that the angle sum in a triangle has to be 180 degrees. 40 plus 60 is 100. So this side length must be 80. Okay, so that's 80 degrees. So I can write this equation here with a single unknown. Okay, sine 40 degrees over length of side A, which is 7 inches, equals sine 80 degrees over the unknown length of side B. All right, so I want to get B by itself, multiply B over. Okay, one more step. Okay, so to see how I get from here to here, well, I want B by itself on one side. So in other words, I want to get rid of this fraction. I want to get rid of a fraction multiplier. So I want to divide by that fraction. How do you divide by a fraction? Well, you multiply by the reciprocal. Okay, so I would multiply both sides by 7 over sine 40, getting this. And at this stage, we can use our calculator. I'll crunch the numbers here right quick. So I will take sine 80. So on this calculator, I got to do the 80 first, then hit the sine. Multiply that by 7 equals, divide by 40, sine equals. So I'm getting approximately 10.7. I guess we should actually go to two significant figures and call that 11. Okay, but it's our first application of the law of sines to find out information about an unknown side in a triangle. Okay, typically it comes up when you know two angles and one side.